Okay, so we've now kind of seen how to recognize what the states of matter are going to be using our solubility rules chart. And we've also recognized that our precipitation reactions are always going to be those double replacement reactions. Okay, and so now we're going to take it one step further, and I'm going to introduce to you what a net ionic equation is. And so what we're looking at with a net ionic equation is, I like to call these net ionic equations kind of the summary or the main event. Okay, and so basically when you have a precipitate formed, or a precipitation reaction, or a double replacement reaction, and you form a precipitate, the big deal is the thing that you can see. You can't see things floating around in solution, but you can see the precipitate that forms. So that right there is the main event. And so a shortcut is that you're going to be taking whatever precipitate is formed, make sure it's coming from a balanced equation, and you're going to basically show the two ions that formed that precipitate at the end, okay? Now, the steps that we actually are going to be running through in our couple examples is, first of all, we're going to have our balanced equation, okay? And while we're looking at the two reactants that are given to us, okay, so as you can see, this is saying identify and write the formulas. So really, you would probably be given these reactants first. So you want to take these and you want to break them into their different little pieces, right? And so once you know what all of your characters are, now we can actually go into the next thing. So you're going to write the formulas of the product. So remember, just like we saw before, you're swapping your ions. So you're taking like the first things listed and you're switching places with them, right? So that's kind of what we've looked at with a double replacement reaction. So we've now written out the products, and you have to determine the solubility. So you can see that you're going to use your solubility rules chart. Okay, so solubility rules. And you're going to put in aqueous if it's soluble, and you're going to put in solid if it's insoluble. Then you have to balance the equation. The reason that's going to be important is because now we're really going to be dealing with the subscripts and the coefficients. So you can kind of see this one is the really complicated, I shouldn't say the complicated, but it's the longer equation, and it's really annoying to write. But you're basically breaking everything into its ions. So let's kind of see what it looks like. So this is what you're used to seeing. A balanced equation, right? So you balanced it, you put all your coefficients in there, and then you're going back to this idea of what are my different characters. Notice we're also putting in their different charges, right? So these are all ions. So we put the Ba with a little 2 plus, then we put a 2 in front of Cl. Where is that coming from? This little subscript, right? That's why it's going to be really important that this is balanced, because if we had a 2 here, that would now be a 4, right? Let me go ahead and delete that little 2. Okay, so now back on this. Okay, so we're going to be paying attention to subscripts, and then we're going to see that coefficients, we're going to make sure we respect that. So we have 2 silvers, we have 2 nitrates. So we're really going to be paying attention to those different charges that are in that list of polyatomics. So it is really useful to make sure that you have your list of polyatomics ready to go, because you're going to be pulling from there a lot. Okay. Otherwise, you're referring to your different Otherwise, you're going to be referring to your different charges that you've already practiced before. So we had like the +1, +2, +3. Then we do -3, -2, -1. Okay. And then these, we'd have to figure it out. Okay. So hopefully you won't see those. but for now, like, remember those basics. Okay. You got to know your charges. All right. So once we have written out that balanced equation, we've now written out each of the ions, so showing the coefficients or subscripts, respecting that and showing that. Now the fun part comes in, where you would take this is called a complete ionic equation, because we're showing all the ions spread out. Now you're going to actually look at both sides, and you get to cancel things out. So that's always fun. So we have Ba2+, we have Ba2+. So those are on both sides, so we're going to cancel those guys out. Then I have 2Cl. I have 2Cl minus, but I don't have any Cl minus over here. I have a 2AgCl, but this is connected to something, so it's not the ion. So this one has to stay. Now I have 2Ag plus. I have again, that AgCl, so that one has to stay. And then I have 2NO3. with a minus sign, 2 NO3 with a minus sign. So 2 nitrate ions. All right, so now what we've done is we've eliminated things that show up on both sides. What you just got rid of was something called a spectator ion. Okay, so spectator ions cancel out. And the reason why is because they're floating around in that solution, right? So they're the whole thing that got dissolved into the solvent. So that is the solution stuff. Those guys are on the outside. The main event is usually your precipitate. Okay, so precipitate. Spectator ions float around. Precipitate is actually showing the thing that's formed. So again, spectator ions, I wanted to get a picture for you guys so you guys could see a little bit more. But looking here, what you see is that you have sodium and chlorine, they're split up. So when things are soluble, right? So that's indicated with this little aqueous. When things are soluble, they're all split into the ions and they kind of just float around in the water. Okay, this would be an electrolyte. This is an electrolyte, right? And here we have silver nitrate. It's also aqueous. So you see that they're all split up. This is also an electrolyte, a strong electrolyte, okay? Then what we see is after we react, we formed a precipitate, okay? So no longer electrolyte, it's not split up, and you see that it formed down here at the bottom. And we have the sodium nitrate now, which is aqueous, and that is the part that remains an electrolyte. So that's what's happening when we have that precipitate forming, okay? So therefore, this is the main event. The rest of this is it's just stuff in water, and you'll literally just see maybe a colored liquid, but it's just a liquid, all right? Which is aqueous because there is solute dissolved in it. So we're gonna go ahead and look ahead and let's do a couple of these just to kind of make sure that we got this big idea, all right? All right, so first thing that we're gonna do is we have this all set up and we're gonna go ahead and take care of our double replacement reaction. So I'm gonna go ahead and underline my two first things that are listed. So I have lithium sulfide and I have silver nitrate. They're both aqueous, right? So these things are the things that are gonna be split up, just like we saw in the last picture. And we are gonna switch those guys' spots, right? So lithium, just as a reminder, from the periodic table, lithium is in group 1, so that is a +1 charge. Silver is not in one of those common ones, but silver is one that always has a 1, a +1. Zinc is always a +2. Aluminum is always a +3. You can kind of remember those in a diagonal form. We're not going to make you remember them. You can always look them up if you need to. Okay, so now that we have that, we're going to switch those guys around. So we have silver, which is a +1, just like we just saw. I have sulfur. So we're going to look at our periodic table. Sulfur is all the way over here. So that's a -2 charge. So I'm going to have the -2 right here. Give myself a little bit of room here. And then we have our lithium, which is that +1. It's in group 1. Nitrate. So I can look right here. Nitrate is up here. So that's a -1 charge. Okay. And the only reason I did that part was first to give me an idea of who my characters are going to be, right? Because we know we're already going to split them, but let's go ahead and get our balanced equation first. So we know that this little 2 is going to come across, right? Just like we've seen back in the day. So we're going to bring a little 2 down here and the 1 goes here. And then we brought this one across, so we have a 1 and a 1. So really what we're dealing with is we have this lithium, Li2S plus AgNO3. All right, so now that we have this idea, okay, we'll get rid of the stuff that we don't need to have visible right here. So let me get rid of that, get rid of that, get rid of that. All right, cool. So now what we're gonna do is we have to balance it, right? So everything is kind of coming together at this point. So we see that we have 2 silvers. So if I'm going to balance this correctly, I'm going to have silver, lithium, sulfur, and nitrate. All right. So I have 2 silvers on this side, but only 1 on this side. I have 2 lithiums on this side, but only 1 on this side. I have 1 sulfur here, and I have 1 sulfur here. And then nitrate, I have 1 on this side, and I have 1 on this side. All right, cool. So we have now seen, we're looking at the green numbers, by the way, okay, that we're going to have to double up the silver. So I'm going to go ahead and throw a big 2 right here, recount. So I have 2 here. I have 2 of these. I'm going to come back over to my product side, and I'm going to go ahead and put a 2 in front of this to fix that. So now I have 2 lithium, so that one's balanced. And now I have my 2 nitrates, that's balanced. So now we're good. So what we're dealing with here, just to kind of give us a fresh view, is our balanced equation is going to be this Li2S aqueous plus the AgNO3, so silver nitrate, sorry, a 2 in front of that, silver nitrate, yields, also aqueous, yields Ag2S, so silver sulfide, okay? And then we're going to figure out that state of matter, plus, and the last one is going to be a 2LiNO3. Okay, so this is kind of what we're looking at here, all right? So we got to figure out these 2 states of matter over here. So we got to know what is the state of matter of our products. So looking at our solubility rules, okay, we're dealing with sulfur. Let me kind of copy that over, help us out. There we go. All right, so we have sulfur. Sulfur is down here. Sulfur is insoluble, so that's a solid, unless it's with one of these. So NH4, an alkali metal, calcium, strontium, or barium, okay? So it's insoluble, or the solid, unless it's attached to one of these things. Well, it's not an alkali metal. Silver is not an alkali metal. It's not NH4, apparently. CaSrBa, those are not those. So this is an insoluble thing. So that means that we just found the precipitate. So we're going to go ahead and label that with an S for solid. That's our precipitate. That's our main event. Okay, looking ahead, that's our main event. Lithium nitrate, we'll just double check that we didn't make 2 precipitates. You can't, but just make sure. And so we have nitrate up here is soluble unless, and there's no exception. So this is our aqueous. Okay, now that we've determined what our states of matter are, now we're going to go ahead and break this down and make this into our complete ionic equation, right? And so we're going to say 2 of these lithiums, which have a plus, there's only 1 sulfur, so I'm going to put sulfur with a -2. Again, I'm grabbing these different charges from the periodic table. Plus, we have 2 silvers with a plus symbol, plus 2 nitrates with a minus symbol. Yields, you have to keep this together because it's solid. It did not break up like we saw in that picture earlier. So this is going to be Ag2S plus, and then we have 2 Li's with a plus 2 NO3s. So just like I said, hopefully you've been keeping up with writing this down, but this is the one that takes the longest, right? And the only reason you do that is so that you can cancel things out. So now that we have it all written out, we're going to go through and we see that, okay, 2 Li's on this side, 2 Li's on this side. So we're going to go ahead and cross those out. We have S with a -2, but there's none on our product side. So we're going to leave that one alone. Then we have 2 Ags on our reactant side. We don't have it on our product side, so we're going to leave that one alone. And you can kind of already see that's the part that became solid, right? Okay. And then last, we have 2 NO3s, 2 NO3s. So we're going to cancel those out, and we write what we're left with. So you see that we have, and I always like to put my metal, so I like to leave it in order of what your precipitate is. So you have 2 Ag plus 1 of the sulfurs with a -2. Yields Ag2S, okay? And then you always have to put the solid. You got to label these guys as aqueous, and that right there is your net ionic equation. Now, please remember, you don't have to run through it this way every single time. You can go right to where the precipitate is. As long as you can write out, you have to have a balanced equation. That for sure needs to happen. But then you can always use that and just write out what your different numbers are with their charges, and you can always just focus in on what the precipitate was that was formed.